Okay, hi guys, it's Miss Funk. I am got 6 problems I'm going to go over and upload, and then it is time for me to go to bed and you to go to bed and get a good night's sleep and be ready for tomorrow. So the first question that I am going to go over is from the calculator portion of the practice test, number 7. Archaeologists found a piece of an old coin. To calculate its original diameter, they drew a chord as XU and its perpendicular bisector ZY. Those two things appear to be backwards because XU is definitely bisecting ZY and not the reverse. Find the coin's diameter. Okay, so what we need to remember is that formula that says that the when two chords intersect, the product of the intersecting parts are equal. So 4 times 4 is equal to 3 times x. That's 16 equals 3x, or x equals 16 over 3, which is 5 1/3. However, they asked for the coin's diameter. XU, you know, is a diameter. How do we know that? Well, because we know that XU is perpendicular to ZY and that XU is bisecting ZY. Anytime you have two chords in a circle where one is the perpendicular bisector of the other, that perpendicular bisector must be a diameter. So XU is the coin's diameter. So we're going to have to take that value for x, the 5 1/3, we're going to have to add 3 to it, and we're going to get C, 8 1/3 millimeters. Alright, I hope that that was not too big of an issue for us. So now we're going on to the next one, which is problem number 10. What is the relationship between the volume of the cone inscribed in a hemisphere and the volume of the hemisphere? So let's start with the volume of a hemisphere. The volume of a sphere is 4/3 pi r cubed. So the volume of a hemisphere is going to be half that, which would be 2/3 pi r cubed. All right? Now, that's the volume of the hemisphere. Let's look at the volume of the cone. The volume of a cone is 1/3 pi r squared h. However, since this cone is inscribed in the hemisphere, the height of the cone is going to have to be the same as the radius. So therefore, this is going to be 1/3 pi r cubed. So looking at the relationship between the volume of the hemisphere and the volume of the cone, we can see that the volume of the hemisphere is 2 times greater than the volume of the cone. Choice B. Okay. Next question. We are looking at number 20, calculator portion of the EOC practice test. When cylindrical cans are sold by the dozen, 2 ways they may be packed in a rectangular container are shown in the 2x6 and 3x4 arrangement below. A can of sauerkraut is 4 inches tall with a diameter of 3 inches. The company manager wants to use a package design that requires the least amount of material. What is the best analysis of the situation? Okay. So, looking at these two arrangements, we know that both of them are going to have they're going to be one layer thick. We're not stacking any cans on top of them. So we are going to need to calculate the surface area of the box that is holding each of these. And if we look in the answer choices, we see that there are some additional options. So let's take a look at what the surface areas are for each of these two proposals. Okay, so since the diameter of each can is 3 inches, that means that this length is going to be 6 times 3, which is 18. The width is going to be 2 times 3, which is 6. All right. So, and then the height is 4 inches. So the surface area of a rectangular prism is 2 times length times width plus 2 times width times height plus 2 times length times height. So that's going to be 2 times 16, oh, no, it's not 16, that's wrong. 2 times 6 times 18 plus 2 times 6 times 4 plus 2 times 18 times 4. And typing that into our calculators, is going to be 408 square inches. Okay, so that's our first option. Our second option, again, the diameter is 3 inches, so that makes this width 12 inches and this height, or this length, 9 inches and a height of 4. So the surface area is 2 times 9 times 12 plus 2 times 9 times 4 plus 2 times 12 times 4. So let's multiply and add. And that's going to be 384 square inches. All right, so we know then that this is a better arrangement than this one is a better arrangement than this one. Okay? Then if we look at option A, we can see that that one's not going to be the case because they're not going to have the same surface area. So we can eliminate option A. If you look at option B, you can see that that reflects the reality of the situation. If we look at option C, that's the one that's got 2 layers. So 6 inches wide, 9 inches long, and 8 inches high. Because we've got 2 by 3 and then 2 tall. So let's take a look at that and see if that surface area is going to be less than any of what we've seen so far. Because just because these two are the two options that were given does not mean that that's the only way that we could do it. So we have surface area is, let me go back and look at the numbers. 2 times 6 times 9 plus 2 times 6 times 8 plus 2 times 9 times 8. So let's multiply. And that does in fact give us a surface area of 348 square inches. So it turns out that that is a better arrangement than the two original options. Okay? All right, and then let's look at the last one. A 1 by 12 arrangement is 3 inches wide, 36 inches long, and 4 inches high. I agree with that. Its total surface area is 3 times 36 plus 3 times 4 plus 36 times 4 equals 264 square inches. That's the part that we have an issue with. They forgot the 2 in the formula. So that does not actually work. So we've got two statements here that are false. A and D are just plain false. All right? A, it's not true that they have the same surface area. D, the 1 by 12 arrangement, that surface area is incorrect. It should actually be twice what they say there. Okay? But in B and C, both of those are right. But they asked for the best analysis of the situation. So we want the one that's going to be the least amount of material, so the smallest surface area. That's going to be option D. Okay? All right, so let's go to the next problem, and next we are going to number 23. A cell phone tower services a 20-mile radius. A rest stop on the highway is 5 miles east and 12 miles north of the tower. If you continue driving due east, for how many more miles will you be in range of the tower? So let's draw this out. We definitely need a graph. We're going to say that the cell phone tower is at the origin. Okay? And the rest stop is 5 miles east and 12 miles north of the tower. So 5, 5, 10, 12, right there. Okay? So the radius of the radius is the radius of the circle is 20 miles. We want to continue driving due east. But of course, we're not going to end up getting to, we're not going to end up getting to all the way to 20 miles east of the cell tower, because we're also north of the cell tower. So this is a horizontal line, and it's the horizontal line y equals 12. We also have a circle which has the equation x squared plus y squared equals 20 squared. So I hope you guys can see that. Basically, what we need to do is we need to solve this system of equations. We need to plug in 12 for y, and we need to solve for x. So that's what I'm going to do. So I have y equals 12, x squared plus y squared equals 400, x squared plus 144 equals 400, x squared is going to equal 400 minus 144 is 256. Oh, that's a perfect square. How nice for us. So the square root of 256 is x equals 16. But that's how far we can travel from due north of the tower. We are already 5 miles due east of the tower. We can go not for 16 miles more, but for 16 miles total. So we can travel 12 more miles. Wait, no, I said 5. We can travel 11 more miles before we are out of range of the cell tower. Okay? All right. Next question. This one was a doozy, and for my students that were at the Monday afternoon review session, we spent a lot of time on this one. It was really challenging. But that's okay. We're going to get through it. Okay, so a cylindrical water tank with radius 2 feet and length 6 feet is filled with water to a depth of 3 feet when in a horizontal position. If the tank is turned upright, what is the depth of the water? Give your answer in terms of pi. So, if this cylinder was full, then we would be dealing with the volume of a cylinder, pi r squared h. So that would be pi times 2 squared times 6, which is 24 pi. So that's the full cylinder. Okay? We, of course, do not have a full cylinder. We have a cylinder that has been turned onto its side and filled to a depth of 3 feet. All right? Unfortunately, just because there is a depth of 4 feet for the cylinder itself does not mean that the volume is 3/4 of 24 pi. That would be lovely, but that's not the case. Because this top section here, it's not going to have the same amount of volume as this middle section here. All right? It doesn't work like that. They're not evenly divided. Okay? What I want to do is I want to figure out if we have a circle because the cross section of the cylinder is, of course, going to be a circle. Here's the center, and here is the water line. This distance is 1 foot. We know that the radius is 2 feet. All right? Here's what I want to do. It's going to be rather difficult to find the area of this part. What we could instead do is find the area of this part. That's what I'd like to think about us doing, and then subtracting from the area of the circle. Why is that relevant? Well, because the volume of a prism of any type is always the area of the base times the height. We have an abnormal base, but we could find the area of the base and subtract. We could find that the area of the missing part and subtract it from the area of the base. Okay. So let's see if I can figure out how to select this. I kept doing it on accident earlier. Nope. All right. So there's my circle. There's a diameter. There's the chord that represents the depth of the water. There is our two radii of the circle. I know that this is 2, and this is 2, and this is 1. All right? This is a right triangle, and I hope that is obvious to us. Okay? The fact that this is a right triangle means that I can now figure out, and I'm now going to be able to figure out this angle. You should notice that the short side is 1 and the hypotenuse is 2. That's very important. That tells us that this is a 30, 60, 90 triangle. So this angle right here is 60 degrees. So is this one. Okay? So we now have angle measures that will help us find the area of, well, we're not going to find the area of that triangle. We're going to find the area of this sector, and then find the area of this triangle, and then subtract it to find the area of this piece right here. Okay? So, the area of the sector is going to be the central angle, which is 120, over 360 pi r squared. Pi r squared is 4 pi, so this is going to be 4/3 pi. That's the area of this entire thing. Now I'm going to find the area of just this triangle. And the reason that I'm doing that is because if I subtract the area of the triangle from the area of the sector, then I'll get the area of this segment, which is what I really want. So, area of the triangle, since this is a 30, 60, 90 triangle, this distance right here is going to be the square root of 3. So is this. So this distance is going to be 2 square roots of 3. So I have the area of a triangle is going to be 1/2 times 1 times 2 square roots of 3. So that's going to be the square root of 3. All right. So now the area of this shaded part is going to be 4/3 pi minus the square root of 3. Okay? So, that is the area of this shaded part. What I'm going to do is I'm going to find the volume of the prism that has the shaded part as a base. And then I'm going to subtract that from the volume of the entire cylinder. So this is going to be, the volume is going to be the height, which going back, the height was 6 feet, times 4/3 pi minus the square root of 3 is going to be 8 pi minus 6 square roots of 3. That's the volume of this cylinder, or this prism. So then the volume of the water is going to be 24 pi minus 8 pi, or open parentheses, 8 pi minus 6 root 3, which is the same as 16 pi plus 6 root 3. That is the volume of the water. All right, we are almost done. That was the hard part. All right. If the tank is turned upright, what is the depth of the water? Well, now we have a more traditional cylinder. Makes life easier. Okay? The volume of a cylinder is, of course, pi r squared h. The area of the base is going to be pi r squared. The radius is 2, so that's 4 pi. So now we need to take this volume and we need to divide it by 4 pi to get the depth. So 16 pi plus 6 square roots of 3 divided by 4 pi is going to be 4 plus 2 square roots of 3 over pi. That is going to be the depth of our water. All right, is that our last question that was asked for? Okay, we have one more, and this one I'm going to have to pull up from screenshots of the YouTube comments. If a tire rotates at 400 revolutions per minute, when the car is traveling 72 kilometers per hour, what is the circumference of the tire? Okay. First off, number 1, this is an angular and linear speed problem, thinking all the way back to trig. All right? We need to take this revolution, or it's similar to that. We need to take this revolutions per minute, or we need to take this kilometers per hour, we need to convert one to the other. Okay? Let's go with the kilometers per hour and convert it to centimeters per minute. So I have 72 kilometers per hour, and I'm going to multiply by 60 minutes. No. 1 hour is 60 minutes. 1,000 meters in a kilometer. 100 centimeters in a meter. So that's going to be 72 times 1,000 times 100 divided by 60. 1,200,000 centimeters per minute. Okay? 400 revolutions per minute. We're just going to take the number of centimeters and divide it by the number of revolutions. So divide 120,000 by 400, and we get 300 meters, or 300 centimeters, which is the same as 3 meters. So the circumference of the tire is 3 meters. Okay? All right, that is it. I'm going to bed. You should too. Have a wonderful night. Good luck tomorrow.